Okay, so this is the very first of our lessons that's been added in as a result of changes to the curriculum last year. So there's two of these lessons to worry about. The first of these is on nonlinear formulas. So we did a bit of this stuff in our very first unit on formula and equations, and you can see here that that's what I've got the title of the sheet down as, and I've called it lesson 9B. So if you want to sort of see what we were doing at the time and how this extends it, go back and have a look at lesson 9, and this will sort of follow on from there. And I just sort of threw in some basic rules. So some of the stuff that we're doing here, we've been doing all year, which is just how to rearrange an equation to change the subject. So we just do everything in the sort of backwards order that we normally do order of operations. So if you use BIDMAS or BODMAS, think of it the other way. So I think of it as SAMDIB. So you sort of try and break apart subtraction and addition first, and then go through multiplication and division, and then indices, and finally brackets. Bearing in mind that when we have fractions, there's kind of a hidden set of brackets, and you can see that there in this example I've given here in the booklet. You've got to kind of assume that when there's a fraction with two terms in either the numerator or denominator, then those terms are sort of in brackets. And this is the big change from what we had to do earlier, and it's not that big of a change, is that so far we've been dealing with, we've always got to do the opposite to break apart with algebra. So if you've got something being added, we subtract it from both sides. If we've got something being multiplied by x or whatever it is we're dealing with, then we can divide both sides. So the opposite of taking the square of something is taking the square root. The opposite of something to the power of 7 is the 7th root. And so that's probably the one thing here that really does change from what we had learned in the past. They hadn't previously had the requirement for you guys to pull apart equations that have either x to the power of n or the nth root of x, and now we've got to be able to deal with those. And the other difference too, of course, is this one here, which is factorization. So sometimes we might end up with a situation where the thing we're trying to break apart is sort of appearing twice, and we don't have like terms, so we can always factorize to bring it out. So we'll see some examples of that as we go through. These first 4 examples are ones we should feel very comfortable with. So let's have a crack at those. We want to make B the subject. Well, what's happening here to B? It's having C added to it, so we're going to take away C from both sides. So we're going to end up with A minus C equals B, and now we've got B as the subject. To have a pronumeral as the subject of an equation is to have it on one side and only that on that side. So we want to get in the form of B equals, and you might even feel a little bit more comfortable always having a subject on the left, so you could just change that around if you wanted to. If you feel more comfortable with that way, that's fine. So for this second example, what's A doing to X? It's being multiplied by X, so we just divide both sides by A to get rid of it, and we're going to then end up with y over A equals X, and there we have X as the subject of the equation. For this next one, we're going to use the opposite of what's happening to E. E is being divided by M, so we're going to multiply it by M, but we have to do whatever we do to one side, we have to do the other. And so that's going to leave us with GM equals E. And then this final example requires 2 steps. Although we want to get M on its own, it's probably going to be easiest in this instance to just get rid of that fraction first. So if we multiply both sides by M, just like we did over here, we're going to end up with GM equals E. Now at this point we can divide both sides by G, and we're going to end up with M equals E over G. All right, so now we're getting into some of the stuff that might be new for you. You probably should have done this in Year 10 Maths anyway, so it shouldn't be that big of a deal. But obviously we've got this situation here. We want to get X as the subject, not the square root of X. We want to have X as the subject. So in order to get rid of a square root, we just come along and do the opposite. We square it. But of course, if we do that, we've got to square both sides. So we're going to end up with y squared equals X. And in our next version here, the opposite of the cube root is to cube something. So if we cube that, then we've got to cube both sides, and we'll end up with m cubed equals n. Okay, now flipping that around, if we want to make x the subject of this equation, we want to make x the subject, not x squared. So once again, the opposite of something squared is the square root. So if we take the square root of both sides, we're going to end up with, my mistake there, the square root of y equals x. And much like the one above, in this one we're going to have to take the cube root because that's the opposite of taking the cube. So it's the cube root, and we're going to have to take the cube root of both sides. So we're going to end up with the cube root of p equals t. Okay, so some of these now will require more than one step. So this is where we have to sort of decide what to do first. So in this particular one, try and sort of, as I said, the opposite of how we'd normally do our order of operations. So normally we'd finish by dealing with pluses and minuses, but in this case we'll start by dealing with them. So this minus 5 really looks like the thing that I could get rid of most easily. It's the furthest away from x. So the opposite of taking away 5 is to add 5. So I just add 5 to both sides. I'm going to end up with y plus 5 equals 2x. Now at this point I'm going to divide both sides by 2 to get x on his own, because that's the opposite, and we're going to end up with y plus 5 over 2 equals x. Alright, so for the next equation, the first thing I'll deal with is that 4. I can easily take that 4 away. The opposite of a plus 4 is going to be a negative 4, but of course I'm going to have to do that on both sides. So I'm going to end up with y minus 4 equals x over 2. Now at this point, I need to, that 2 is dividing x, so I need to do the opposite. I need to multiply 2 by x. But I also then have to multiply everything on this side by 2, bearing in mind that it's everything. So it's like I've set brackets up there. And remember, when we've got brackets like this, we just multiply that term by both of the terms in the brackets. So as we do that, we're going to end up here with 2 times y is 2y. 2 times minus 4 is minus 8, and that's going to equal x. Okay, to make b the subject of this equation, probably the easiest thing is to take away a and c from both sides. So if we take away a, we're going to remove that. When we take away c, we're going to remove that. But of course, we've got to do that from both sides. So as we do that, we're going to end up with 2b equals minus a minus c. And obviously now we've got b being multiplied by 2, so we can just divide that by 2. But if we do that, we have to divide the whole of the other side by 2, not each of them, the whole of it. And so as we do that, we're going to end up with b equals minus a minus c over 2. Okay, for example D here, once again we'll deal with that that minus 3 by adding 3 on. So we'll plus 3 to both sides. We'll rewrite that again, just make one change each time and make the necessary changes to make that work. Now this isn't the 5th root of x, this is 5 root x. So the square root of x is being multiplied by 5. Now if we think about order of operations and going backwards, we would do multiplication before, if we're going backwards, we did multiplication before we did indices, and obviously square root is looked at the same way as an indice. So the first thing I'm going to do here is divide that by 5. Which means I've got to do that to both sides. We're going to end up with y plus 3 over 5 equals the square root of x. Now, last of all, I'm going to deal with that square root. So the opposite of a square root is to square. So I'm going to have to do that to both sides. So I rewrite that out, and I'm going to have y plus 3 over 5 all squared equals x. Okay, I'll probably have to split this lesson in half, but we'll keep rolling for now. So for this next one, once again, I'm going to deal with getting rid of that 5 first. So I'm going to take away 5 from both sides. That's going to deal with that nicely for me. So I'll rewrite that as y minus 5 equals minus 2x squared. Now, I'm going to deal with that index last in this situation. If I was following BIDMAS or BODMAS, that would be one of the earlier things I do. So going back the other way when we're rearranging, we do it at the end. So the best thing I can do here is get rid of that -2 out the front. So if I divide this side by -2, that's going to get rid of that -2 in front of the x. But I'll have to do that to both sides. So I rewrite that as y minus 5 over minus 2 equals x squared. So now the opposite of squaring something is to take the square root. So I'm just going to have to do that to both sides. And I end up with the square root of y minus 5 over -2 equals x. How are we doing for time? Just a little bit left. Now this one, I've effectively got a hidden set of brackets. Because all of this is under the square root sign, it's kind of like they're all in brackets. So although normally I do multiplication and division first, if we think of BIDMAS or BODMAS, the very first thing is brackets. So in other words, when we're going backwards, when we're rearranging equations, that's the very last thing we're going to break open. So if there's anything else we can do first, we'll do that first. So in this particular case, while there's an index we've got to deal with, that square root sign, it's something we would do before we dealt with those brackets. So in order to break that open, we're going to have to square that side, which means we're going to have to square the other side as well. So we're going to end up with v squared equals mr over pi. At this point, I can get rid of that denominator. I can multiply both sides by pi, because pi is dividing r, which is what we're interested in, but I've also got to obviously multiply both sides by pi. So I'm going to write this as pi v squared equals mr, and then obviously the next thing I need to do is get rid of that m. So I'm going to divide both sides by m because it's being multiplied by r at the moment, and I'm going to end up with pi v squared on m equals r, and I've got r as the subject of that equation. So we've got two more before we get into some more problem-solving ones, so I'll do these two and then we'll break there. So a equals pi r squared, well that looks like the area of a circle. The first thing I notice is that r squared is being multiplied by pi, so it should be pretty easy to get rid of that pi. I'll just divide both sides by pi. So that's going to give me a on pi equals r squared, and the opposite of squaring something is to take the square root, so I have to do that to both sides and end up with the square root of a on pi equals r.